Hi everyone! Today we're going to be going over Leetcode problem number 21, Merge two sorted lists. The key takeaway for this problem is getting practice with using the dummy head approach. With that said, let's go ahead and get started. So this is problem 21, Merge two sorted lists. You are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. So we aren't actually creating any new nodes. Our output list is made by splicing together the existing nodes in list 1 and list 2. Good to know. And finally, we return the head of the merged linked list. Alright, so let's look at their example 1. List 1 has nodes 1, 2, and 4. And list 2 has nodes 1, 3, and 4. And the output node is a linked list with nodes 1, 1, 2, 3, 4, and 4. So it looks like the first one came from list 2, the second one came from list 1, the 2 came from list 1, the 3 came from list 2, the first 4 came from list 1, and the second 4 came from list 2. So it looks like whenever we have two nodes of the same value, such as the 1s in the beginning of the output list and the 4s in the end of the output list, it doesn't really matter which node comes first, the one from L1 or the one from L2. Because the first 1 came from L2, but the first 4 came from L1. Okay, let's look at example 2. List 1 is empty and list 2 is empty. So our output is also an empty linked list. This looks like an edge case that they just want us to be aware of. And moving on to example 3, list 1 is empty and list 2 just has a node with 0. And the output is just going to be a node with 0 in it. So this looks like another edge case with just a single node in one of the lists. Alright, so that's a pretty good range of test cases. In the first test case, both lists have a decent number of nodes, and the output list is made up of nodes from L1 and L2 interspliced. And example 2 and example 3 are good edge cases to keep in mind. Okay, so I think that's pretty comprehensive. I would have asked if we are creating new nodes for the output list, but they already specify in the problem that the output list is made by splicing together nodes rather than creating new nodes. So that's enough information to get started with making our plan. So in this problem, we first have to find the smallest element, then the second smallest element, then the third smallest element, etc., until we merge the two linked lists. So anytime we're doing something repeatedly like this, we can either do it recursively or iteratively. I'm going to do this problem iteratively, since it feels more intuitive to me to merge elements one by one rather than recursively. And since we're taking an iterative approach, we're probably going to need a dummy head. So in this case, the dummy head is helpful because we can use it to build our output merged list, and we don't have to treat the head of our output list as a special case. We can just create that dummy node and add all our nodes to it one by one. So the first step of our plan is going to be to create a dummy head. We will end up returning the dummy head's next node as our return value. Alright, so let's go ahead and use the example 1 they provided us to brainstorm our solution. L1 is 1, 2, then 4. And L2 is 1, 3, and 4. And the output list consists of nodes 1, 1, 2, 3, 4, and 4. Alright, so since we need to build our output list, let's create a pre-variable that we can build off of, and we can initialize to our dummy head. Okay, and the next step is to compare the heads of L1 and L2 and set prev.next to whichever element is the smallest. And we need to break ties somehow. So let's just say L1 wins the ties. So in this case, the 1 from L1 is just as small as the 1 from L2. But we said L1 wins ties, so we just used the 1 from L1. Then we update whatever list we used to add to the output list, and we also update our previous variable. So in this case, we use the 1 from L1. So we update L1 from 1 to 2. And then we update prev from our dummy head to 1. Then we repeat the previous steps and continue adding to our output list. So in this case, the 1 from L2 is smaller than the 2 from L1. So we add the 1 from L2 to our output list, and then update our variables accordingly. Through the same process, we add the 2, the 3, and the first 4, which comes from L1, since L1 breaks ties. Now for the second 4, we don't even need to compare L1 and L2, since L1 has no nodes left. So the next step in our plan is if either L1 or L2 runs out of nodes, we just set prev.next to the rest of the other list. So in this case, we set prev.next to the 4 from L2, since L1 has run out of nodes. And we're done. We've finished merging L1 and L2 into one fully sorted output list. So here's the plan that we came up with, all written out. Let's now take it over to our text editor so we can start actually coding up our solution. Okay, so the first step is to create a dummy head and return the dummy head's next value. Alright, so let's go ahead and do that. And the next step is to create a prev variable and set it to our dummy head. We will use this prev variable to build our output list. So let's go ahead and do that. And then we set prev.next to the next smallest element. And we've decided that L1 breaks ties. So if L1 has the smallest value, breaking ties, we set prev.next to L1. And if L2 has the smallest value, we set prev.next to L2. And then we update L1 or L2, whichever one we used to add to our output list. And we also update prev to be the new node that we just added, so that remains the tail of our output list. And then we repeat adding variables to our output list. So let's add all this code into a while loop. And step 6 is to repeat until L1 or L2 runs out, in which case we set prev.next to the rest of the other list. So let's add a termination condition to our while loop. So we want to continue while both L1 and L2 still have nodes. And after we break out of our while loop, we'll set the rest of our output list to whichever list still has nodes left. Alright, and that's it for our code. It's looking good so far, but let's go ahead and run it on some examples. So we used example 1 to create our plan, so let's instead go through our code on example 2 to make sure that it works on this edge case. So L1 and L2 are both empty, so we immediately break out of our while loop, and since both L1 and L2 are none, we don't update prev.next to the rest of the other list, and we just return the dummy head's next node, which is none. And so our output matches our expected output, which is none. So that test case passes. Let's try it on example 3, another edge case. So L1 is empty, and L2 is a single node with 0. So since L1 starts off as empty, we don't even enter our while loop, and we just set our output list to the non-empty list, which is L2. And so we just return a node with a 0. Alright, so it seems like our code works on the example test cases. Let's run it on all the test cases. and it passes. Okay, so now that we have working code, let's evaluate the time and space complexity of our solution. So the time complexity is n plus m, n being the length of L1 and m being the length of L2. This is because we end up having n plus m nodes in our solution, and we're building our solution one node at a time. And the space complexity is actually O of 1, since we are using existing nodes from L1 and L2 and splicing them together to create our output list, rather than creating new nodes for our output list. Alright, and that's it for today's problem. Remember, the key takeaway for this problem, merge two sorted lists, is practicing using the dummy head approach. Hopefully this was helpful for you, and thanks for listening.